Okay, let's talk about robots. I mean, these things are incredible, right? They're some of the most powerful, most precise tools we've ever made. They build our cars, they even help with surgery. But for decades, actually programming them has been this kind of walled garden. You had to be a super specialized expert to even get in the door. So what if we could just tear down those walls? Well, stick around, because today we're going to look at how that's finally starting to happen. So you got to ask the big question right up front. Why in the world is programming a robot so hard? I mean, really, why has it been so complicated for so long? Because that complexity, that's the one thing that's been keeping this amazing tech away from, small businesses, artists, all the everyday innovators out there. Yeah, this really lays it all out, doesn't it? It's the perfect picture of the gap we're trying to close. Over on the left, that's the old way. It's a total maze of complicated code that takes years to get good at. But on the right, that's the goal. That's the future we're headed for. A world where you can just show a robot what to do or tell it using simple, natural instructions. A total game changer. So here's how we're going to break this down today. First, we'll tackle what I'm calling the expert wall. Then we'll get into how visuals started to simplify things. After that, we'll look at the leap into programming without any code at all. And finally, where this is all going, having a natural conversation with a robot. It's going to be a journey from the problem to a future that's, well, pretty amazing. All right, let's dive into that first section, the expert wall. This really is the heart of the problem, the huge barrier that's kept robotics as this exclusive club for so long. So why has it been so tough? Well, it's not just about writing the code to begin with. The real nightmare, the thing that eats up most of the time and money, is handling errors. Think about it. What happens when something goes wrong? And get this, if you want the robot to do a new task, forget about it. You're basically starting all over again from scratch. That is the expert wall we're talking about, and it's been a major roadblock. Okay, so how did we start to break through that wall? Well, the first big crack appeared when researchers started asking a really simple but powerful question. What if we could just see what the robot is thinking? And that's what led to the first real breakthrough, using visual interfaces to make all that complexity easy for anyone to understand. And a really key piece of technology here was something called IRMCS. Now, don't worry about the acronym. The main idea was to build a kind of bridge, an interface that could let a total non-expert look at what a robot was doing, actually understand it, and, this is the important part, jump in and fix things when they went wrong. And here you can see what that bridge actually looks like. So on the right, you've got all the complicated raw data that the robot is crunching. It's just noise to most of us, right? But the IRMCS system is the magic translator. It takes all of that noise and turns it into what you see on the left, a clean, simple visual flowchart. It completely demystifies the machine. Let's make this super concrete. This is really the heart of it. Instead of a bunch of confusing code, a task like pick up an object and put it down gets broken into these really simple steps. You've got home, open hand, approach object, and so on. And check out the simple color coding. It's brilliant. Green means everything's good, yellow means it's working on it, and red means oops, there's a problem. For the very first time, you could see not just that something went wrong, but exactly where it happened. And the results? Honestly, they were jaw-dropping. When they had regular people, total novices, try to fix a robot error using the old-school coding method, their success rate was 0. A flat 0%. But when they used this new visual interface, 94% of them succeeded. 94! That was a massive realization. It proved the problem wasn't the people. It was the terrible tools they were being forced to use. Okay, so people could finally understand what a robot was doing and even fix it. That's a huge step forward. But the next leap was even bigger. The question became, great, but how do we teach a robot something brand new from scratch without writing a single line of code? And the answer was kind of a brilliant reversal. It was about stopping this crazy idea that humans have to learn the robot's language, and instead finally teaching the robot to understand ours. And how do we communicate? We use the most natural tools we have, our hands and our voices. And this is so cool. It shows you exactly how it works. You have a camera that tracks your finger moving around in 3D space. You literally just point and draw the path you want the robot to follow in thin air. That's it. The system sees that gesture and translates it directly into a command for the robot. You're programming by just showing it what to do. And again, the results were just a total game changer. Just look at these numbers. The old school way, with what's called a teach pendant, took over 90 seconds to program a simple task. Hand guiding was a little better. But this new no-code method, the one using just gestures, we're talking under 29 seconds. And by the fourth try, it was under 18 seconds. That's more than 3 times faster. It takes a boring, tedious job and makes it quick and, well, kind of fun. All right, this brings us right up to the cutting edge. This isn't science fiction. This is the future that's happening right now. We're moving past just following simple gestures. We're building robots that can actually understand context and what you're trying to do, kind of like a human assistant. And it's all being powered by AI. And this quote from the president of ABB Robotics just nails the vision perfectly. Listen to this. We want to enable the manufacturer to tell a robot to bend wires and put them on a specific object. See the difference? The goal isn't to meticulously program every single movement. It's to just tell the robot the high-level objective and let it figure out the how all by itself. So you're probably wondering, how does that even work? Well, it all comes down to generative AI. These new systems are combining what a robot can see with its cameras with the power of large language models. This allows the robot to not just see an object, but to understand what you want to do with it. The endgame here is something experts call an agentic architecture. And all that really means is building a system that can think for itself, one that can reason, plan, and act, instead of just blindly repeating movements it was programmed to do. And just so we're clear, this isn't just some cool lab experiment. We're talking about a massive economic shift. The market for this kind of stuff is projected to hit over $290 billion by 2029. And you can bet that this new, much more accessible, AI-powered robotics is a huge, huge reason for that insane growth. So let's pull all this together. What does it all mean? Well, we've basically traveled from a world where robots were kept in cages and only a handful of experts could talk to them, to a future where pretty much anyone can teach a robot a new trick. This is nothing less than the democratization of robotics. You know, for decades and decades, the whole story of robotics was about one thing. It was about us, the humans, having to bend over backwards to adapt to the machine's complexity. But now, that entire idea is being flipped on its head. The future is about making the robots adapt to us. And that leaves us with one last really fun question to think about. Once this technology is truly in everyone's hands, we're talking artists, chefs, scientists, you name it. Once you could teach a robot to do literally anything just by showing it or telling it, what's the very first thing you'd teach it?